Hi, everyone. My name is Felicia O'Garrow, and for my final project, I actually worked on a Shopify product tagger. So the problem. So tagging products on Shopify, it sounds straightforward until you're doing it at scale. And then you can run into different inconsistencies. It could become very costly, and the process can actually be very long and slow. So the goal was to build a pipeline that automatically assigns the right taxonomy tags to any product, given just its title and description. For this project, I actually built out a multi-agent pipeline. I felt one model couldn't handle every case well, so I didn't want to try to force it. I really wanted to build a solution where each product would actually route to the right model based on confidence. So fast when sure and more powerful when not. And here's my system architecture. So you start off with a product, and then you have the title plus the description. There's the preprocessor, the BERT inference, the model selector, the tagger, and then the validator agent. And just to go a little bit deeper into those five different agents, you have the preprocessor, which tokenizes and deduplicates and enforces min and max length. You have the BERT classifier, which is a fast inference plus confidence estimation. Then there's the model selector, which routes based on max confidence score. And then you have the LLM API tagger, which uses Claude and GPT as a mini fallback. And then there's the validator, which flags low confidence or tags sparse predictions. Now, as far as this pipeline in general, BERT does double duty. It's both the confidence estimator and the primary tagger. The other two paths only activate when BERT isn't sure enough. As far as the routing policy, you have the max confidence, which is greater than or equal to 0.75, which would route to BERT. If the max confidence is greater than or equal to zero point 0.5, it would route to Laura Mistral. And in all other cases, it would route to the LLM API. Now, the goal with this is to keep most of the traffic on BERT since it's fast as well as affordable. The different methods and why these models. So BERT, I decided BERT was good as far as the fast because it's trained on 110 parameters. It's fine-tuned end to end on product text. As far as Laura Mistral, it uses QLoRa base weights quantized to 4-bit, and only low rank adapters are trained. And then you have the few shot LLM, which is a 5-shot prompt with full taxonomy plus example product. As far as the data, I use the McAuley Lab Amazon Reviews 2023 Hugging Face data sets, my train test split. And with that, I have my training set, which was a little bit over 61,000, and then validation and a test set with a little bit over 7,600, which gave me a total amount of data, which was 76,378. Taking a deeper dive into the data, there's 21 Amazon categories that map to 30 taxonomy labels. As far as the data, I had to load that in. I had to actually use streaming to load the data so that no disk overhead would be on Colab. As far as the average labels per product, it was 1.08, and the label coverage was 24 over 30. And then there was 24 out of 30. And then as far as the validation test, it was 23 out of 30. And then there were 23 labels with no non-zero test F1. And here's a glimpse of the different taxonomy labels. These are the full 30, which are all designed to directly map to Shopify's standard product taxonomy. Now, as far as results, BERT was actually used as like the main model. So as far as BERT's baseline results, you had a micro F1 of 0.856, a macro F1 of 0.652, a Hamming loss of 0.011, and a coverage error of 1.528. So as far as the training curves, you could see the different charts. So I have one for the training and validation loss and the validation F1 over training. The loss and validation F1 was over 5 epochs. As far as micro F1 peaks, epochs, 5 epochs. And there was no overfitting observed. So per label, the F1, I found that there were 7 labels that had zero or insufficient usable coverage and scored zero. The 23 covered labels performed well with 5 above F1 that equaled 0.93 and a macro F1 that equaled 0.85 across covered labels. As far as the results for Laurel Mistral actually outperformed Bert on every metric after just 3 epochs. As far as those numbers, there was a micro F1 of 0.868. The macro F1 for all 30 labels was 0.662. The macro F1 for 23 covered labels was 0.864. The Hammond loss was 0.010, and the coverage error was 1.478. Latency comparison. Um, this trade-off is exactly why routing actually matters. BERT handles high confidence products in 15 milliseconds. Laura Mistral only fires on ambiguous inputs, and the LLM API is a last resort for like truly out of distribution cases. So I actually also did an evaluation just based off of the LLM being the fallback, and I used Claude Haiku for that. So as far as the micro F1, it was 0.60. The macro F1 for all 30 labels, it was 0.411. And the macro F1 for the 20 covered labels was 0.617. So I found that the micro F1 is 0.256 below BERT, which is expected for a model with no fine tuning on this distribution. And the primary role for this model was basically just to handle cases that were out of distribution for the products. As far as the routing results, so these were some of the different results for just like the routing in general, where the validator like flag BERT. So BERT is confidently wrong on zero coverage categories, and the max confidence is not a reliable OOD signal. The routing logic is correct, but the uncertainty measure is not. So you can see like Levi's, straight jeans, clothing, sports, outdoors. That was the predicted. And then the max confidence was 0.97. And as far as the failure mode, it was high confidence wrong. And here are a few just like example predictions in general. And actually, in the notebook, I have an interactive Gradio demo where you could actually go through. It's pretty much a live product tagger with full routing visibility. So you just input the product title plus the description. Then you'll get an output of the predicted tags with the confidence score. And then the routing decision panel, which the model ran, why, and why was it flagged. And that was actually built using Gradio. So you can check that out in the notebook, which I'll give you a quick glimpse of. As far as strengths, limitations, and future work, What work? Cover labels are strong. They're pretty much 8 and above, and the F1 is 0.90. Laura Mistral beats Bert on every metric after just 3 epochs. As far as cost efficient by design, most traffic never even touches a paid API. So, what didn't work? 7 of the 30 labels had zero or insufficient usable coverage. And I also found that Bert is overconfident on low coverage categories. So as far as my conclusion, for this system that I built, as I mentioned, I have the different agents. So the preprocessor um, focuses on the product text and deduplicates before anything else. Um, then you have classification where it classifies as with BERT at 85.6%, the micro F1 15 milliseconds per product. As far as the routes, ambiguous cases will route to Laura Mistral or the LLM API. That as far as validation, it validates every prediction before it goes back to the merchant, and it stays pretty much affordable. Most traffic never even touches a paid API. The project on GitHub. So if you want to check that out, definitely check it out. Um, as far as the notebook itself, I can give you a quick glimpse. Here is actually the Shopify product tagger. As I mentioned, you have a few different use cases that you could actually plug in and just play around and test that out. And then, as far as the notebook in general, you can see that I have everything aligned in different phases, everything starting from phase 1 to phase 5. And that's pretty much my project. Thank you so much for your time. And I hope you guys enjoy just checking it out.